Welcome to Simplified Engineering. This is video lecture number 11 and the topic is PdV work or displacement work. In IC engines, that is internal combustion engine, what we use in automobiles, cars, bikes and all, where we get the work output by burning the fuel and during the expansion of the air fuel mixture after burning. So the analysis of that kind of a system, that kind of a cylinder is very important. So we are explaining that displacement work concept with a simple piston cylinder arrangement here. Inside the cylinder there is some amount of gas which is at a very high pressure. So the diameter of the cylinder is D and the length is L1. So the pressure inside the cylinder is P1 and volume is V1 and temperature is T1. If the pressure inside the cylinder P1 is higher than the atmosphere pressure, that is the pressure acting outside the piston, if it is higher, then there will be expansion, which means that the piston will move upwards like this. Okay, so we can write the initial volume V1 is equal to area into L1, where area A is equal to pi by 4 d square. This is simple mathematics. After expansion, the pressure is P2 because it will be much reduced, and the volume is V2 and the temperature is T2. So the final volume I can write V2 equal to area into length L2 because area remains the same. And at any intermediate point where the pressure is P and volume is, we are going to find the infinitely small work done, which means that for a very small displacement of the piston, what will be the work done, and we will integrate that work done to get the total work done during the point state 1 to state 2. So during at intermediate point we can find the work done, but work done we know that it is just force into displacement. The infinitely small work done dW is force into infinitely small displacement dl, where dl is a very small displacement during the piston motion. But we know that force we can write pressure into area. At any intermediate point the pressure, let it the pressure be P. I am denoting it as P. So force is P into A. So we can write the dW as the work, the infinitely small work done as P into A into dl, where dl is the infinitely small displacement. But area into displacement, that is what we will got the volume, infinitely small volume. I can write P into dV, that is pressure into infinitely small volume change. That is the displacement work. I can get it by integrating the equation, that is W12, that is work done from 1 to 2, that is integral V1 to V2 PdV. That means that if you are integrating the infinitely small work done during a small volume change dV, I will get the displacement work as V1 to integral V1 to V2 PdV. This is what we call displacement work. There are other kinds of works, that is other than displacement work. We will be explaining those kind of work in other lectures, and this is the basis equation for displacement work where the pressure is constant. Okay, this is the end of this lecture. In the next video we will be explaining the displacement work and PV diagram, how we can mark the displacement work in PV diagram, how we are getting that. So we will be explaining in coming lectures. Thank you for watching. You can subscribe for latest videos. Thank you.